Hello dear students. In this video, we will see some more programs by using control structures. The first one is printing reverse of a number. What is our aim is, when the program runs, user should be asked to enter some number. Let's say user enters the number as 18 and hits enter. Then the output should be 81, reverse of this number entered. Now, don't be under an impression that the number entered by the user will be always two-digit number. It can be any number. For example, the number might be 183. Then the output should be 381. Or it might be four-digit number. Or it might be even one-digit number. So if the user enters a value, say 5, then the output has to be 5. Reverse of 5 is just 5. So what is the logic? What is the idea behind printing reverse of a number? Just see if the number is n and number entered, let's say, is 128 by the user. Now, the problem is we want to print 8 first. What if we apply a formula like this? R, which is another variable, is equal to n%10. Now, that means we are operating 128%10, and you know 128%10 is 8, last digit of 128, isn't it? So R is 8 here. Notice that we are successful in taking the last digit of the number n in the variable r. R is 8. So how about printing r? We can print r. I am writing in short algorithmic notation. The actual syntax, actual grammar will be done in the program. But then if you print r, then 8 will be the output printed, isn't it? 8 is printed because r is 8. Now, what if we apply a formula like this? N should change. We are saying n should become n divided by 10. Now, applying the value of n here on the right hand side, n is 128 divided by 10. Remember, it's not 12.8 because both here n and 10 are integers. So 128 upon 10 is 12, and that 12 is stored by n. So n, which was 128, has now changed. N has become 12. Observe this. N has become 12. Okay. So the new value of n is 12. It was 128, but due to n is equal to n by 10, n has become 12. Now you just think of that if you repeat these sentences again using some loop, we will see what loop we will use over there. But just imagine these lines are repeated. So you are again evaluating r is equal to n%10, but n is 12 now. It was 128, but n has changed to 12. So now 12%10, as you all know, is 2. So r is 2. Last digit of 12, isn't it? So we are successful in taking out the digit 2. First, we were successful in taking out digit 8. Now digit 2 is stored in r. And how about printing it? So the next line is print r, which will print 2. Just check, the number was 128 and 82 has got printed till now on the screen. Now the next line says n should change. N should become n by 10. But n is already 12. 12 by 10 is 1. It's not 1.2. It's 1. So n now becomes 1. N, which was 12, is now 1. Okay. I'll again erase some working over here. Remember the latest value of n now, it was 12, but now it has become 1. Okay. Now what if we repeat this for the new value of n, where n is 1? So r is again evaluated as 1%n. Now you all know 1%n is 1, so r is 1. And how about printing it? So 1 also gets printed. Check the output till now is 821. And then this line n is equal to n by 10 is going to evaluate n as 1 by 10. Now 1 by 10 has to be 0.1, but remember it is integer division. It won't be 0.1, it will be 0. So n, new value of n is 0. N, which is 1, now becomes 0. So remember n was 128, then we extracted 8, then we made n as 12. Okay, when n was 12, we extracted 2, last digit. Then n was made 1. When n was 1, we extracted 1, and then we made n as 0. Now, when n is 0, you will agree that there is no sense in repeating, because it seems that we have extracted all the digits and we have printed them on the screen. So the summary is that these 3 lines are going to do the work for us. But these 3 lines are to be repeated as long as n is not equal to 0. When n becomes 0, this loop should stop. Or you can say as long as n is greater than 0. Isn't it? Whatever. But when n becomes 0, the loop should stop. So, what is the loop then? How do you write the loop? You know, even while speaking, we will say while n is greater than 0, as long as n is greater than 0. So, the best loop we can write here is while n is greater than 0. While this is true, brace open, brace close. Keep repeating these lines. Isn't it so? And when n becomes 0, 0 greater than 0 is false. So the loop will break and next line will run. That is what is exactly written over here. Now the grammar was already explained. You can see that the code written over here for reversing a number, n is the number, r is the remainder. We ask the operator to enter the number, and as long as n is positive, greater than 0, take the last digit. This is the line which takes out the last digit from n, and we print that digit. R is the digit. And then n is equal to n by 10 is supposed to strip off the last digit. Just check. If n is 128, what will n is equal to n by 10 do? This is 128 upon 10. So the new value of n will be 12. Just observe, we are stripping out the last digit. So this line is supposed to cut the last digit from the number, and this line is supposed to find out what is the last digit so that we can print the last digit. I hope you have understood. You can just dry run on paper. You can run it with some example like what if n is 106? What is n? If n is 106, first time the loop is true because 106 is greater than 0. So r evaluated, check this line, is 106% 10, correct? Which is 6. So r is 6. So the next line printf will print 6. But then n becomes n by 10. If n becomes n by 10, it is 106 by 10. 106 by 10 is 10. So new value of n is now 10. Okay. Now imagine that you are going back to while and rechecking the condition. The condition now is n still greater than 0? It is. Give me some time again. It is. N is greater than 0, isn't it? Because n is 10 and 10 is greater than 0. So hence, when the loop repeats, r becomes n% 10, but the new value of n is 10. So 10% 10 and 10% 10 is 0. So r is 0. So the next line here prints r, that is 0, and then n becomes n by 10. If n becomes n by 10, then n becomes 10 by 10 because new value of n was 10. So n becomes 1. 10 by 10 is 1. So remember, now the value of n is 1. If the value of n is 1, still the loop will repeat, isn't it? Just let me clean a few things. Still the loop will repeat because n is 1 and 1 is greater than 0. So now the line r is equal to 1% n is going to evaluate r as 1 and 1 will be printed. But now this line n is equal to 1 by 10, 1 by 10 is 0. So n becomes 0 finally. When n becomes 0, next time this loop is not going to repeat because 0 greater than 0 is false. So the number was 106. First r became 6. We printed 6. But then n became 10. We stripped off this digit. Next time r became 0, last digit of 10. And n became 1. We stripped off this 0. And next time r became 1, last digit of this number 1. And n became 0. When n becomes 0, we stop. So this is how you print reverse of a number. I hope you have understood. Next problem is also printing reverse of a number. But then what is this program doing, This program is actually constructing reverse of a number. Please try to understand. In the previous problem, we printed reverse of 128. But how? We actually fooled the user by first printing 8, then printing 2, then printing 1. But what if a number n is given as 128 and our program should actually construct a new number which will be 821? Let's call it as rev. Some variable rev should store 821, reverse of this, and then we will print the value of rev, which is 821. That is what is done. Again, this problem also prints reverse of a number, but it actually constructs the reverse. So you can see that the logic is same. But here, apart from n and r, we have got one more variable rev, as you see, which is 0 initially. And we are asking operator to enter the value of n. Let's say value of n entered is 128. Now this while will repeat because 128 is positive, greater than 0. So the line r is equal to n% is going to compute r as 8, last digit. Correct? Now solve this line with me. Rev becomes rev into 10. So rev becomes 0 into 10 because come on, rev is currently 0. So 0 into 10 plus r, and notice r is currently 8. So rev becomes 8. The new value of rev is 8. And now solve this line with b. N is equal to n by 10. So n becomes 128 upon 10. As you all know, n will become 12. So the new value of n is 12. Okay. Now, during the next repetition, n is still greater than 0 because notice n is 12. So r becomes 12% 10. 12% 10 is 2, last digit. R is 2 now. And now you solve this line with me. Rev is equal to rev into 10. But rev is already 8. So this is 8 into 10 plus r. Notice r is this time 2. So rev becomes 82. The new value of reverse is 82. Remember the number was 128. Hello, remember number was 128. Now reverse is 82. And now you solve the next line. N is equal to n by 10. But n is already 12. 12 by 10 is 1. So n is 1. So the new value of n is 1. Okay. So now let's go back to while. And while will repeat, obviously. Because n is 1 and 1 is greater than 0. N is 1, 1 is greater than 0. So the next line here, r becomes 1, isn't it? 1% n. Now if you solve this line, rev becomes rev into 10, but rev is already 82. So 82 into 10 plus r is 1. So this becomes 821. Rev becomes 821. New value of reverse is 821. And then n is equal to n by 10 will be n is equal to 1 by 10, and 1 by 10 is 0. So the new value of n is 0. Now tell me, if n becomes 0, this loop is going to break because n is no more greater than 0. We are sure that when the loop breaks, n is 0. But rev clearly gives us reverse of a number. Output of this will be 821 and the number entered was 128. I hope you understood. Running the program on the paper by simply substituting the values and finding out how reverse will be formed. Now, the next code given here is check whether a number is palindrome or not. We will see this code execution in the next video. Thank you very much.